Okay, so this one 5.3. Let's see. So what do you guys notice about secant and cosine? Yeah, anyone?
1 over cosine of secant.
Okay, so 1 over cosine. Okay, so which is what secant? So this one would be 1 over cosine square of x. Minus 16 over cosine of x, right? Yeah, we can do that. So now everything is written in terms of cosine. So what can we do next?
Trying something.
What happens if you don't want to deal with the rational expression?
Yeah.
You don't want to deal with the denominator? What can we do?
Find a combinator.
Back to algebra 2. Common denominator, which is?
Cosine squared of x.
Cosine square of x, right?
Yeah.
Can we just simply multiply everything by cosine square of x?
Yeah.
Yeah? Because we want to get rid of the denominator.
Oh, yeah.
And then distribute, so we got 1 minus distribute
1 minus 16 cosine
16 cosine x. And then the right hand side, we do the same thing, right? Multiply. So cosine to the 4th power of x, right? And then minus 16 cosine cube x.
I brought everything to
Aren't we
one
not
side.
supposed to work across the equal sign?
What's that?
Aren't we not supposed to work across the equal sign?
Yeah, but the thing is that
Just
we just want to multiply by the common denominator first.
okay.
And then try to bring everything all together. So now, what happens when we try to bring everything all together? Now we got 0 equals cosine to the 4th power of x. Minus 16 cosine cube x. And then plus cosine of x, 16 cosine of x. And then minus 1. So back to algebra 2. So what kind of pattern is this? What kind of polynomial is that?
Vortex.
Okay, polynomial, right? Can we factor this by grouping?
That's what I was thinking.
Yeah, is that possible?
Yeah.
But how do you group them? Does that matter which way that we group this?
Yeah, it does.
Yeah, Kritika, what do you think? The way to group this? It's polynomial.
Yeah, you need to group it so that you can like take the like terms out.
Okay, take the like terms, so maybe like the first two together, right? And then the last two terms.
Yeah, but the 16 kind of fits.
Yeah, but the thing is that, keep that in mind, we can swap the terms around. So what do you notice? You try to group the first two terms together. Any greatest common factor involved for the first two terms?
Cosine cube of x.
Cosine cube, right? Yeah, but you try to do it that way.
What if you group the second and third?
Group the second
And
and
then
third
the
together,
first
and then the
and
first,
first,
okay,
about
let's do that.
16.
So instead of doing this way, so let's group the first and the last.
Yeah.
Because we can apply the difference of 2 squared,
Yeah.
right?
Yeah.
What
Yeah,
else?
you can.
Yeah, good.
Yeah.
And then the second and the last, right?
You have
I mean the
cosine.
second and the third.
Mhm.
And then minus, and then take 16
Mhm.
cosine squared of
Yeah,
x.
let's do that.
Uh,
Would that work?
Cosine.
So we got cosine square of x minus 1 times cosine square of x plus 1. And then the other one, we just take out, what, negative 16, right? Negative 16 cosine of x.
Yeah. Cosine
So we
squared
got-
of x. Cosine. Oh wait, never mind.
So we got cosine square of x minus 1, right? You guys see that?
Yeah.
Good. So now, what's the common binomial here? Things that they share in common of those two
Cosine squared of
groups.
x minus
Cosine square of x minus 1. And then the rest of this. Okay, so it's cosine square of x minus 16 cosine of x, and then plus 1. Right? You guys all agree? Yeah? So what I did here, I just take out the common binomial, cosine square of x minus 1, and then the rest of this, just rewrite it. Yeah? Now, what about the trinomial? Is that factorable? Can we factor it?
No.
You sure?
Yes, negative
Wait,
16.
yeah, but it's negative 16, right? So that one is non-factorable. So how do you solve for, how do you find a 0?
Quadratic formula.
Quadratic formula for this one, right? But what about this?
Oh, that's easy.
That one just said equal to what?
Plus minus 1.
Cosine square of x
It's
equals
just
what?
difference of 2 squares.
Yeah, difference of 2 squares. We can do that.
So cosine of x.
So
equals-
cosine of x minus 1, cosine of x plus 1.
So cosine
And then set that equal to 0.
equals 1. So what about cosine? Cosine of x is just 1.
So that means cosine of x equals 1, and then cosine of x equals negative 1. So what are those two solutions?
It's 1 comma 0. Yeah.
Wait,
So-
we need the radian.
Yeah, hold on.
Pi? Hold on.
Yeah,
No, no,
one.
no, no, no.
So that's 0, 0. 0
Okay,
degrees.
let me
Oh,
ask you, Tika. So
Zero
what do you
and
think that
pi.
is? On a unit circle? So this
Oh.
one, if
yeah,
that's
it's
0, so
0
that's
and
1
pi.
comma 0.
Yeah, 0 and 5.
Over here, pi, then that'd be negative 1 comma 0.
Yeah.
So x equals plus
So that
pi
means for this one would be what? 0, right? 0 radian.
and pi.
And then the other one is just pi.
Okay, and then the second one.
And then, but what about this? This one is non-factorable. If that's non-factorable, then we use the quadratic formula.
Yeah.
Yeah.
Yeah? But the thing is that by the time you use the quadratic formula, you're not solving for x. You're finding cosine of x.
Yeah. Yeah.
What's the quadratic formula again?
Negative b plus
Plus minus, right?
square root of b squared.
Minus 4ac
Minus
all
4ac
over
all
2.
over 2.
So negative 16, so positive 16 plus minus 16, negative 16 quantity squared, minus 4 times a times 1 times 1. And then it's all over 2. So what do you notice? What's 16 squared? Is that 256?
Yeah. Minus 4.
Minus 4?
equals
252?
Yeah.
But the thing is that it's a non-perfect square number, right? Would that be possible?
I mean, depends.
Yeah, it could be. I
Yeah.
mean, it's positive, so it's not imaginary.
Because that's greater than 1, and also is less than negative 1, right?
And also, there's not a negative.
Yeah,
Yeah.
so that means, guess what? It's out of the range. Remember the cosine graph? Cosine graph, what's the range for cosine of x?
0 to.
It's a bell curve, right? Which is what? From negative 1 all the way to 1.
Wait.
So this one, there's no solution.
No. Look.
Is that possible?
Yeah, it is.
You sure?
Yeah, Mr. Chen.
Yeah? Did you divide it by 2? You did.
Yeah.
You got a perfect number?
Yeah, no.
It's going to be
0.06.
decimal, right?
106. And now all we have to do is take the.
Take the inverse, right?
Yeah, take the inverse.
Now it's a calculator. So what is it? What's that decimal right there?
Hold up. Let me just check.
What?
It is 1.5. 1.5 is also an answer. Who is that? Bruh. Yeah. So 1.5 is 1.51 is also an answer.
So try to take the inverse of this. Inverse of what? 16 plus root 252 over 2, right? Did you take the inverse of that number?
Which one? Yeah.
Yeah. So what is that about?
1.5.
1.5 radian.
Yeah.
What about for the
Oh,
negative?
wait, let me check whether it was in radian or in degree.
This one should be in radian.
Yeah, that's a.
That's what we need.
Yeah. Well, it is in radian, yeah.
Right?
Yeah.
Wait, but are you sure that? Okay, let me check.
Yeah, you can check yourself.
So inverse of cosine of 16.
It's just 16, right? It's
Okay, guys. So just do that on the calculator and see what happens. So make sure that the mode gotta be in radian. It is. And then so we take the second inverse of cosine of the quantity 16 plus root 252.
No, it's 16 minus root 252.
16 minus, not
Yeah.
plus.
Yeah. 16 plus is obviously not right.
And then that quantity. What else do you need to do?
I divide that
You
two.
put it in. Okay, let's start it. So second inverse cosine quantity. Okay, that's what I got. 16 minus root 252. Parentheses again, divided by 2. Yeah, it's about 1.5. Yeah? Did you guys have we got? Because this one, once you divide it, it's a decimal minus. So if that's a decimal, that means we can just find the inverse. It's a non-special ratio, so we use the calculator for this. Okay? If that's a special ratio, like root 3 over 2, 1/2, you know, we can just find the what? The special angle. Okay? What about for the positive? Positive is not part of the solution? No, it's not, right?
The positive is like.
Yeah. If that's a plus, then that's going to be a big number, right? It's greater than 1. So we only got 3 solutions for the 0, pi, and 1.5 radian. So what do you think about this type of problem? Okay?
Okay.
Okay, so now, you guys want to try, let's see. What about 2a? Okay guys, let's try 2a. So sine of 3x equals 1 plus cosine of 3x. And you might be wondering, wait a minute, it's a triple angle? It's kind of like triple angle, but the thing is that we can simplify it.
Which one?
2a.
2a.
Yeah, under the same section, 5.3.
Oh, you don't really need to. You just need to divide the answer by 3.
Right,
Yeah,
eventually.
whatever you
Right.
write, you
Once
can
we take the
just
inverse.
divide it by 3. You don't need to do the.
Yeah, that one is. Okay, so let's see. So for the trig chapters, so the hardest stuff is about the trig identity and also solving using inverses. Anything other than that, they're pretty straightforward. Like graphing using the unit circle and also the one cycle. Okay, so for that one. So we got sine of 3x. So that equals 1 plus cosine of 3x. So anything that I can combine, subtract, put them all together, what do you think?
I mean, you could just.
Identity maybe? Perhaps.
If we squared everything.
No, but
that
then
would-
you'll have.
No,
Now,
it doesn't work with
Uh-huh.
this.
try to square it? Yeah, we can square it.
No,
No,
because
because-
That's
the
possible.
identity
But then
itself-
you'll have the like plus 2
Cos-
cosine 3x.
Right.
What are you gonna do with that?
We can rewrite it in terms of cosine.
Oh yes, we can. No,
Can we do that?
Yeah, square into right answer.
Can we square both sides?
Yeah.
Really?
Yeah,
1
you're
plus
right.
2 cosine.
So we got sine square of 3x. So that equals 1 plus 2 cosines of what? 3x.
And then we could convert the
Plus
left hand to
cosine
1
square
minus cosine
3x,
square.
right.
What's it?
And this one we can convert that into what?
1
Oh, you
minus
put it to
cosine.
the third
Yeah,
part.
It's supposed to be like cosine square of 3. And then this one use the Pythagorean identity. So 1 minus cosine square of 3x. Right? Good.
Minus 5. Okay, so you can do
Good strategy. And now, anything that we can cancel on both sides?
1.
Uno, right? Now, since well, what is this? This one is quadratic, right? So that means we need to bring everything together. Okay, so we'll try to bring everything together. So what is it? So we got 0 equals 2 cosine of 3x. And then plus 2 cosine square of 3x.
0 equals 2 cosine 3x.
Mhm.
2 cosine.
Right?
Cosine.
Do you guys all agree so far?
Yeah. Plus 1. Okay. So then you end up with like a
Greatest common factor? What's the greatest common
2
factor?
cosine of 3x.
2 cosine of 3x.
So you can just send which of cosine? There's 0 comma 1 and 0 comma negative 1.
Okay, wait, slow down. Lunch. So 1 plus 2 cosine of 3x, right? Like that. Yeah? You guys all agree? Now imagine that 3x is just like theta. Can we do that? Yeah? So instead of dealing with 3x first, let's just imagine that it's like theta. So this one basically just like 2 cosine of theta. You let theta equals 3x. So I'm just using like a substitution variable. And then 1 plus 2 cosine of theta. So instead of solving for x, so we solve for theta first.
Yeah.
Right? It's easier to deal with this. So that means we do have two possibilities. So either 2 cosine of theta equals 0, and also what else? 1 plus 2 cosine of theta, what is that equal to? 0, right? So let's try to solve for theta first.
It's pi over 6 and pi over 2.
Okay, so cosine of theta equals 0, so that means cosine, well, theta gonna be what? Pi over 2? 3 pi over 2, right?
Yeah.
Because the unit circle, again, up here, 0 comma 1, down here, 0 comma negative 1. Pi over 2, 3 pi over 2. But what about this? So this part right here, so that will give you cosine of theta. So that equals negative 1/2, right?
Wait.
Yeah, minus 1 and then.
Again, we're solving for theta first. Okay? And then after that, then we solve for
Oh wait, you did
then
something
we solve
wrong.
for x.
You did something wrong.
I did something wrong?
Yeah.
Like what,
Here?
factoring?
Yeah. When you took out the 2, you forgot. This is.
Oh, there's no 2 right there? Because we took out 2. Thanks. So it's only what? It's only 1 plus cosine of theta. You're right? So it's only 1 plus cosine of theta. So that equals 0. Good. Which is?
Pi, and that x equals pi over 3.
Pi, right? And then we solve for x. Again, x, we do know that 3x equals what? Theta. So whatever that we have for theta, we divide everything by 3. Right? So that means we end up with pi over 6, 3 pi over 6, which is what? Pi over 2, right? And then the other one is what? Pi over 3.
Number 3 is probably the hardest one though.
What do you think? The way to deal with the triple angle? Yeah? Wait, which one is the hardest one?
3 looks like the hardest one.
Number 3? Oh yeah? You want to try that one?
Sure.
Well, before you try that one, can you guys do 2b first? You guys so try 2b, because that one is kind of similar. Proportionality. How do you guys deal with the proportionality? Back to geometry. If that's like a ratio,
cross multiply.
cross multiply. All right, good. And also for secant and cosecant, you can always convert it to what? Sine and cosine. If there's any easy way for doing this type of problem? Okay, let's try that one.
It says check the extraneous solutions.
Yeah, so whatever the solution that you find out, you want to check that. Because that denominator cannot be 0, right? So once you see the denominator, so that means whatever the solution that you have, you need to plug in the number and find out, make sure that it's not going to be 0. Okay, so now let's see. So it's getting a little bit more difficult. Well, basically they're all difficult, but it depends on, you know, the pattern or the strategy that you apply. So we can make it simpler. Okay, so for that one, so 2b. So 1 over cosecant of x over 1 plus cosecant of x. So that equals 1 plus secant of x. All over 1 minus secant of x. Now, before you guys cross multiply, anything that we can do? Should we rewrite it in terms of sine and cosine first?
Or you can expand it and then
Yeah, expand it. Okay, well, let's just rewrite it in terms of sine and cosine. So we got 1 over sine of x, and then 1 plus 1 over sine of x. Well, the purpose of rewriting it, so we want to simplify it, right? And then the other one is 1 over cosine of x. 1 minus 1 over cosine of x. So you guys can tell me about the least common denominator on the left hand side. Sine x, okay? Yeah. So multiply by sine x, top and the bottom. So basically I just want to rationalize it, right? And now what about the right hand side? Cosine x, least common denominator. So now, what would you do? After you find the least common denominator, multiply that top and the bottom. So the next step, you want to distribute, right? So sine x minus 1, right? And then denominator, so sine x plus 1. And then the right hand side, pretty similar, so cosine of x plus 1 over cosine of x minus 1. And now from here, guess what you can do? Cross, multiply. Like that. So cross multiply, we have sine x minus 1, so times cosine of x minus 1. And then cosine x plus 1 times sine x plus 1. Like that. And it looks like we need to FOIL, right? So
You don't even need to convert it back into.
Yep. So sine x cosine x minus sine x minus cosine x plus 1. And then the right hand side, pretty similar, cosine x sine x plus cosine x sine x, and then 1. Anything that we can cancel. Any term that we can cancel on both sides?
Sine x cosine x?
Yeah. What else can we cancel? What about that 1 right there?
I read sine x plus cosine x equals 0, but then I don't know what to do from there.
Okay, so now what do you do after that? Can we combine the like terms together? So we got negative sine x minus cosine x equals cosine x plus sine x.
If we take out
Let's
the
bring
negative-
everything together.
Yeah.
So we got 0 equals what? Well, let's just collect the like terms. So let's put the cosine x together. So we got negative 2 cosine x equals 2 sine x, right? Is that what we got so far?
Yeah.
Linear?
That's exactly what I reached, yeah.
Can we cross out the 2?
Yeah, and then just put everything to it.
Now, watch. Can we divide it by negative cosine x on both sides? So what does that become? If we divide it by negative cosine x.
Oh, negative tan.
So we got 1 equals negative tangent. Negative tangent of x. In other words, that means negative 1 equals what? Tangent of x. Okay?
We could do, yeah, tan of
And this
x
one, it goes
equals
all the way from 0 to 2 pi. So what are those solutions?
negative 1.
Back to the unit circle. So if that's negative 1 for tangent, so that means quadrant what?
Quadrant 2 and
Quadrant 2 and 4, right?
2 and 4, yes.
So over here, then that'll be what? 3 pi over 4, right?
Yeah.
And then it also could be what? 7 pi over 4, right?
Yeah.
Because that's 45 degrees for the reference angle. So that means x is 3 pi over 4.
Okay. Now we need to
Then
check
7
it
pi.
for that.
And then you just plug in a number to check the extraneous solution. Oh, they're both considered valid.
Yeah.
So they all. What do you think? Hey, what is this all about? That's not even trig, right? That's like algebra 2. Right? Distribute, rationalizing, cross multiply, FOIL, algebra 2, algebra 1.
Only the
and
last
trig.
2 steps are actually trig.
Yeah. That's why you guys go algebra 2 first, right? Before trig. Yeah. So now you guys can try number 3. So try to use the similar strategies, but the things that if you find out anything that's considered like the trig identity, so make sure that you try to apply that trig identity. So what are the identity? Pythagorean. So that's the one we have gone through so far. The ratio identity, or the reciprocal. Okay? But this time you want to find out the solution from negative pi to pi. So that's from negative pi to pi. That means it's going this way. Negative pi all the way back to pi. Counterclockwise.
But that doesn't make any difference. All you have to do is find.
Yeah, but the thing is that it's going to be like negative radian instead of being positive radian.
So you go.
Yeah, you're going this way.
Like.
Right?
Yeah.
The one that we've been doing is
Oh,
like
yeah, like
from
go
0
the
to
other
2
way.
pi.
Okay, should we just start?
That's right, right? Negative pi all the way back to pi. If that's a negative angle, that means you're going by clockwise first. And then
Right.
positive angle, counterclockwise. Yeah, so try that one and see what happened. Okay, so 1 plus 1 over tangent square of x. Again, if any trig identity that you see right here, so try to use that. Okay, so for that one, so just want to write the problem here first.
Oh, this is extremely simple. Oh wait, no, it's not.
Is that extremely simple?
Yeah,
Yeah?
I think so.
Think so?
I don't want to jinx it, but.
Okay. So how do you guys get started with this?
Just
Turn 1 over tangent squared x into
So that one just turned into cotangent, right?
And then 1 over.
And then the other one is like what?
Tangent.
Tangent, okay. Okay, so that's a good way to get started. What's 1 plus cotangent square of x? Is there any identity for that?
Yeah. Cosecant
What is it?
squared x plus x.
That's just like secant, right?
Cosecant.
Cosecant or secant? Oh, cosecant, that's right. Cosecant square. And what about the other one? 1 minus tangent square of x. Any identity we can apply for that one? Yeah? Katika? Now one thing that we noticed, secant square, it's like 1 plus tangent square, right? Yeah?
plus minus.
That doesn't apply any identity, right? So this one, just leave it.
We could put it in terms of sine.
Yeah, so now we can just rewrite it in terms of what? Well, basically we can just set it equal to 0. Can we just set that equal to 0?
Yeah.
And then just solve for x, right? So this one, that means sine of x. Wait, is that possible? It's 1 over sine of x equals 0. Is there any solution for that? 1 over sine of square of x equals 0. Would that be possible? Well, the top part is 1. The numerator is a constant, but the denominator cannot be 0. So what happened?
I found it.
So this one, no solution, right? But what about this? So tangent square of x equals what? 1, right? Square root. So we got what? Plus minus 1? Right?
Yeah. Yeah.
What are those
that's
solutions
right.
there?
Plus minus pi over 4, comma, plus
Uh-huh.
minus 3 pi over 4.
So basically those 4 rates, right?
Yeah, and you don't need.
So negative 3 pi over 4.
Yeah. And the second part of the equation is
Plus
literally
minus
just,
3 pi over 4, right? Because this one's going back to this. And then the other one is what? Negative plus minus pi over 4. 4 solutions set. Do you guys all agree?
Yeah. And the second one is no solution. Because
Yeah, this one, no solution. Right? Yeah, it's good to go. It's all about the inverse with the unit circle. Yeah, TT? Alright, let's see. So now, you guys ready for something else?
Sure.
Proof.
Okay.
The rest of this is all solving. You guys can do that more extra practice. But now, if you look at that on page, well, there's no page. So this one is section 5.4. sum and difference formula. Can someone tell me about the sum and difference identity? Well,
Oh, wait, yeah, just learned it in class.
just learned in class recently?
Yeah.
Yeah, let me give you this
Yeah.
first.
Same.
And that's something we actually cover in trig. But now this one is just more in depth. And now she already got one,
Yeah.
right? Okay. So if you look at that, the sum and difference, but I'm going to show you the proof for this. Okay? And first of all, can someone tell me about the identity for sum and difference? Like cosine and sine?
Cosine
Like sine of what?
sine
Well, according to the formula sheet, what does that say? It's like sine of alpha plus beta, something like that?
using x and y.
Wait, what is it?
It's using x and y.
Use x and y,
Yeah,
okay?
so it's
Easy.
sine of
Okay.
x, cos of y,
Okay, I'll just put it right.
plus cos.
Okay,
Sine
so
x cos y.
cosine of x plus y,
Yeah, equals.
or cosine of x minus y, and then sine of x plus y, and then sine of x minus y.
And then
What else? Tangent, right?
I
Man, that's a lot, huh?
Yeah.
Yeah.
We
You
just
only
had
need
a
to
quiz
do one.
yesterday.
You only need to do no three.
You just need to prove one of those. You just need to prove one of those.
Plus, I think
And then we can use the
proved it in
cofunction.
one
I'll
of
show you that in a minute.
Oh, yeah,
no,
the 90
yeah.
minus. Yeah.
Okay, ready?
We did it in like our homework.
Oh,
Okay.
you have to do that.
So now, before I'm going to show the formula, you
It's
see
just
that, the circle right here?
show you.
Can someone tell me about those two unit circle? What do you guys notice? What kind of triangles are those?
Equilateral?
Are they just considered equilateral, isosceles, or just like a regular?
It's equilateral.
Now, what else do you see right there on the unit circle? Do you guys see that segment D?
Mm-hmm.
Mm-hmm. Yeah? Hidika? Do you see that segment D? Now back to geometry. How do you find out the distance of a line segment on the xy
Oh, the
coordinate
angle.
plane?
Formula?
Distance formula. What's the distance formula again?
Square root of
Square root of x2 minus x1 quantity square and
plus y.
y2 minus y1 quantity square. So here's what I would like to do. For those two capital D, I would like to set up the distance. Okay, the distance on the for segment D on the left hand side. So what is that? So it looks like that one's going to be what? Square root of cosine of A minus cosine of B quantity square. What else? Plus sine of A minus sine of B quantity square. Okay, so that's the left hand
But
side,
wouldn't we be able,
the left circle.
like since we already know that it's equilateral, wouldn't we be able
We don't know whether that's equilateral or isosceles. It's just a regular triangle. But one thing for sure, we do know that D, those are the exact same distance. Because they're both bounded by the radii. Okay? Yeah, it's isosceles because the radius, okay? And now what about the right hand side, the circle on the right hand side? How do you set up that distance formula? Can someone tell me what that is? So that one would be what? Cosine of capital A minus B minus minus 1, right?
Yeah.
Yeah, minus 1. Quantity square. And then what else?
Cosine of.
Wait, cosine again?
Sine of.
Sine. So basically I'm just using the distance formula right here. Like that, right? You guys all agree? Hey, what about the radical? Can I just cancel out the radical?
Yeah.
Because when she squared both sides, the radical got canceled. Right?
I don't understand how you set them equal to each other.
Because it's the same distance.
Wait,
By using the geometric theorem, what happened with that segment D? Are they both being bounded by the radii?
Yeah.
Yeah? What is this angle right here? Back to circle on the left hand side. So that angle is right between what? Angle A and angle B, right? So that means the other one is just the what? The difference of angle A and B.
Yeah, it'll be
And
the
by
same
using the
value.
angle segment here, back
it'll
to
be-
geometry.
It'll be the same D.
Yeah. What's the name of that theorem? The hinge. The hinge theorem. Remember that?
Yeah.
Remember the hinge theorem back to
Yeah.
geometry?
Last week.
The corresponding angle, that means it has the same ratio as the what? The corresponding segment. Yeah.
There were a lot of questions.
So now, radical, basically we just cancel them out. And now, what can we do? Can we just expand it?
Yeah.
Yeah? What happened? You try to expand it. Anyone? Difference perfect square, right?
Yeah.
So cosine square of A minus 2 cosine A plus cosine square of B. Right?
Wait, no,
Wait,
cosine A,
wait.
cosine B.
Right here?
No. Minus 2 cosine A.
Oh yeah,
cosine
minus
B.
cosine A, cosine B. Forgot one thing here. What about the other part? Plus
Plus
sine square of A minus 2 sine A
Sine B.
sine B plus sine square of B. Okay, so you guys all agree? Right? Expansion. And now, what about the right hand side? And Katika, can you explain that, the way to expand it?
So for the first one,
Mhm.
since it's just cosine A minus B.
So that one's just like cosine square of what? A minus B, right? Like that?
Minus B.
Minus 1, minus 2 cosine of A minus B, and then plus 1, right? Again, it's a binomial expansion. And what about this? This one is just like what? Sine square of A minus B, right? Plus sine square of A minus B. Now the rest of that is getting easier. Any trig identity that we can apply. Can we apply the Pythagorean identity? Yeah? What's cosine square of A plus sine square of A?
Oh, that's one.
That's 1, right? Right here. 1. What about this?
Another one too.
That's another 1, right? What is that? So 1, 1 plus 1.
Yeah, 2.
2.
And then 2
Minus. Can we combine this
Yeah.
together? Wait, are they exactly the same thing? No, they're not.
No,
So just rewrite it. So minus 2 cosine A, cosine B, minus 2 sine A,
you can remove the 2's.
sine B. Right, we're going to do that
Oh, yeah.
later. What about this, the right hand side?
You can use this.
Can we
one.
combine them? So 1 plus 1. Because this one is,
Yeah.
well, once you combine them, what is that? Identity, right?
Yeah, so.
So 1 and then plus 1. So then 2 minus 2 cosine of A minus B. Wow. Getting there. What can we do with the 2?
Yeah.
Wait, before we take out the 2, can we just cross out the 2, the constant?
Yeah.
And then we took out the what? Negative 2, right?
Yeah, all.
So we got cosine A, cosine B, plus sine A, sine B equals negative 2 cosine of what? A minus B.
And then
What can I do with the negative 2?
you can cross out the negative.
Proof.
Oh, okay.
What do you think?
Wait, you just like solved for the actual sum and difference.
Yeah? We just find the what? This one right here.
Yeah.
Now how do you prove the rest of this?
Just
You
change.
could just like swap.
Can we use the cofunction property?
Yeah, 90 minus.
Yeah? How do you apply the cofunction property?
You have to say.
You could.
What would you do?
It was like.
What's the
pi-
cofunction
pi
property?
minus- oh, sine
Think about it.
pi over 2.
Remember that cosine of 60 degree is the same as what? Sine of what? 30, right?
Yeah.
So what's the cofunction property? So like cosine of theta, it's the same as what? Sine of 90 minus
Theta.
theta.
Yeah.
So how do we apply that?
It is sine of 90 minus A plus B. Yeah. But that would be weird.
That'd be weird. Well, this one you just need to change that. So instead of cosine A, what is that?
That becomes sine of.
That one becomes what? Sine of
90 minus.
90 minus what? A. Right? And then we just want to prove this one. And then the rest of that, instead of using cosine, we're using what? Sine. So the rest of this is just using the cofunction property. But I just want to show that the first one, it's about using the what?
I
The
remember
distance
doing
function.
this in algebra 2. It was so boring.
Did you guys do that in algebra 2? What, in Washington?
Yeah, at the sum and difference.
Oh.
It was like, she give the same thing and just say sine of pi.
Uh-huh.
over
Yeah, the
2.
proof part is always kind of
No, the
Crazy.
proof is fun.
Yeah.
I'm talking about like when the guy be, oh, what's the sine of 75 degrees, and you have to expand it out.
Okay, so now I'm sure you guys have the formula already. So now let's do 2a. So what happened with that 2a? So tangent of negative 11 pi over 12. It's a non-special radian. So what can we do? Can we make it to special radian?
Yeah.
Yeah? How?
Copy.
So tangent, well, what's the sum and difference of tangent? Tangent of x plus tangent of y, right? Over 1 minus tangent of x, tangent y, right? And the difference just like switch the sign, right?
Yeah.
Okay, so now for that one, so this one is considered one single radian. But now, can we make it as 2 radian?
Yeah.
By using, can you split it?
Pi over 6 minus pi over 4.
Pi over, negative pi over 6 and negative pi over 4?
No, just pi over 6 minus pi over 4.
Pi over 6 minus pi over 4? But is that the exact same quantity?
Yeah. Okay.
Check that. Yeah? Would that be true?
Yeah.
Common denominator, then that'd be what, 12, right?
No. Hold up, no, that wouldn't work.
No.
No.
Can we use
That'd be
this?
7 pi. No, it's 7.
Negative.
Wouldn't that be 5 pi over 4? I do not know what I'm saying.
I think you're just guessing. Hold on. Sweet.
Think about it. Any thought, Kika? The special radian? Can we use negative pi over, okay, negative pi over 6? What else? Plus, well, negative pi over 6 is like negative 2 pi over 12. What about negative 9 pi over 12? Which is what? Well, this one is just like negative 2 pi over 12.
Yeah.
Does that work?
No.
Because this one turns out to be negative 3 pi over 4, right?
Yeah. And then negative pi over.
You guys see that? Why I need to use the negative? I mean the 2 radian? Because those are the special angle. Another thing is that tangent. What kind of function is that for tangent? Is that odd or even?
It's odd.
It's odd. So that means tangent of negative x is the same as negative tangent of x. Can we do that?
Yeah.
So that means this one is the same as negative tangent of 11 pi over 12. So instead of using negative, we're using what? Positive. But outside, you want to take out the negative.
Yeah.
Yeah? And let's try to simplify this a little bit. What's 2 pi over 12?
2 pi over.
Reduce.
Pi over 6.
Pi over 6. 9 pi over 12. How do you reduce it?
3 pi over 4.
3 pi over 4, right? Okay. Now, and I would like to find out what you do with the rest of this. By using the identity.
Formula.
Which one? This sum, right?
Yeah.
Yeah, let's try that. You guys see the setup here? So you have to simplify the setup. And then you try to expand it. So negative tangent of pi over 6. And then plus tangent of 3 pi over 4. And then it's all over 1 minus tangent of pi over 6. Tangent of 3 pi over 4. Back to the unit circle. What's tangent of pi over 6? In other words, what's tangent of 30 degree? Katika, what do you think that is? Root 3 over 3? It is, right? Tangent of 3 pi over 4, Aditi?
1? Wait.
Negative 1,
Negative
right?
1, yeah.
Quadrant 2. And then the rest of this, so it's just add root 3, right? Over 3. Because negative times negative, which is what? Positive. Now what else can we do? Can we rationalize it?
Yeah.
Yeah, to get rid of that 3. Multiply
Yeah.
3 top and the bottom.
Yeah.
Yeah, like this.
Yeah.
Yeah? So what will be the final form? Well, the negative, just leave that outside. No need to bother it. Okay? So we got root 3 Positive, negative, negative, minus 3 over denominator 3 plus root 3, right?
Yeah.
Or we can just swap this. Root 3
You
plus
can
3.
take out the negative to make it the same.
What else do I need to do?
Take out the negative. Oh, it just becomes
Yeah,
negative
I
one.
already took out the negative. That's why
Yeah,
it's-
that just becomes negative 1.
Rationalize?
Yeah, what do you need to multiply top and the bottom? Back to algebra 2.
Root.
Multiply by root 3
Root
minus
minus
3, right?
Yeah.
The conjugate. Wow. See the problem? From trig back to algebra 2, right? So what is it?
That would
Root 3 times root 3?
3.
Well, this one you could just expand it if you want to. So 3 minus 6 root 3, right?
Yeah.
And then plus what? 9. Again, the negative, we'll just leave that outside. And then all over. Denominator, what does that become?
3 minus 5. Oh, negative 6.
3 minus 9, which is what? Negative 6. Okay, so I need more space, so let me put it up here. So now, what's the final form? 3 plus 9, and that'll be 12 minus 6 root 3 over negative 6. But don't forget, the negative is outside. What's negative times negative?
Positive.
So we got 12, 6 root 3 over 6.
2.
And then reduce,
Two
so
minus.
2 minus root 3. Wow. What do you think? A lot of work, huh?
Yeah.
Yeah? Tedious. It's all doable. Yeah? So we got just started with this. Sum and difference.
Oh,
We just had a quiz yesterday on 7.1 and 7.2.
Okay. Like what?
That's
Pythagorean identity, basic.
Verifying
Both sides.
and
Yeah.
then-
Alright? Katika? Okay, so why don't we take a break first, 5 minutes, and then after that we're gonna continue with the SAT practice.
Wait, I want you to try it.
Oh yeah, the questions that you have.
Oh yeah, one second.